So let's take a look at this one. We have our capacitors. The first thing we should solve is the series circuit. So we're going to do the reciprocation. 1 over 20, 1 over 30 equals 1 over C. Should end up with 12 farads here. Then these are in parallel. So now we're just going to simply add them up. Okay, so 10 plus 12 gives us 22. So this is our equivalent resistance. Then we're just going to start solving for missing things. You'll always be missing Q at the end. So Q equals CV, so that's 22 times 120. Okay, so what's my Q total? Alright, we're going to go back to this circuit. And actually we don't have to put Q on this circuit. We'll just be using it for a check. So this one, if you notice, it's parallel, so we already get the full voltage. So the voltage across the 10 is 12, voltage across the 12 is also 120. Or 10 is 120 and 12 is 120. So we're just going to find the Q's for each of these. Q equals CV, so that's 10 times 120, which is 1200, and then 10 times 12 times 120, 1440, and they should check out to 2640 when you add them up, this plus this. Okay. Now remember, the 10 farad was one that we didn't fix. This was already all by itself, so we know the voltage across that was 120, and we know the charge stored on that was 1200. So now all we're going to do is remember that for a series circuit, series set of capacitors, they have the same charge. So that means the Q for both on this branch right here is going to be 1440 for both. So the 20 and the 30 are both going to get 1440. And the only missing thing now is the voltage across each of these. So now we're going to use the version Q over C. So 1440 divided by 20 and 1440 divided by 30. Okay, so what's the first one? Second one? These should check out, right? These two should then add up. The voltages of these two should add up to the total 120. And then to find UC, we're just going to go across. Okay, Judy, can you just read them out to me?
72,000. 51,840.
How much?
51,140. And 34,560.
Okay, confirm. All right.